Watch carefully. If you weren't here last time, we spent a long time on this, so I would go back and review the class video. So I might not go quite slow enough for you to learn it for the first time, but I'll try. Okay? So the first thing we do is we've got to take this thing, we've got to reduce it to something we can solve. And we can't solve this because it's like some crazy parallel series sort of thing. But a 7 and an 11 is the same as a 18? Yeah? Okay. Do I have this circuit right before I keep going? Yeah, that's good, right? And then the 18 and the 13, notice that their ends are connected together, so we surmise that those guys are parallel, right? And that's going to be 1 over, please be quiet. Okay. 1 divided by 18 plus 1 divided by 13. And I'm going to store that in alpha A. Okay. So this is 7.548. And that's stored in my memory location A. And last time we practiced storing stuff. It's in the thing over here. Okay. Last time we practiced storing stuff in memory locations, but that's 7.548 ohms, right? And now we can solve this circuit. It's just a simple series circuit. Battery, resistor, one 7.548 ohm resistor, and 5 ohms, right? Okay, so we just do what we do. This is a series circuit. We can solve series circuits, right? Okay, so the current in that circuit is 17, so it's this guy here, right? Right? 17 divided by 3 plus 7.548, which I've stored in A, right, and 5. Okay, so my current is divided by parentheses 3 plus, and literally I'm typing into my calculator alpha A plus 5. And I'm storing this in alpha B. So this current is 1.093 amps. Guys, can you be quiet, please? Dylan and Brad, I love you, but okay. Okay, why didn't he pay attention to me? Okay, so 1.093, that's the current in that circuit. That happens to be, is there an ammeter? Yeah, there it is, right? That's the reading on that ammeter. Right? Now I can pick off the voltage on this guy here, the V2, right? So V2 is going to be IR. It's a series circuit. That's what we always do, right? Okay? So it's going to be 1.093 times, and then that resistance is 3 ohms, right? So I'm going to go times 3. And is that right? 3.280 volts. Am I getting them right? All right. All right. Okay. And then I think that's it, right? Those are all the meters. Now, there happens to be a voltmeter across this sub-circuit. This guy looks like he's just across the 13 ohm resistor, but if you follow these wires, I could have just as well connected it here and here and drawn it here. V1 could be drawn here as well and have the same exact reading, right? Because I can just slide these leads along this thing. I've got nothing but wire, correct? This is all one piece of wire here, and that's all one piece of wire, so it doesn't matter whether I connect it there, where it looks like it's just over the 13 ohm resistor, or if I connect it right here, where it looks like it's over that whole sub-circuit, it's the same thing. This voltmeter is across all this resistance, not just the 13 ohm resistor, okay? So for V1, I'm going to do the same thing. I'm going to do IR, and it is the reduced circuit, right? Okay, so now I'm all set. That one is 1.093 times, what did we say? That was 7.548, right? Now this is somewhat comically, this is just B times A in my calculator, which is Ba, right? Okay, so I'm going to go alpha B times alpha A. And I'm going to store that in alpha C. And that's 8.253 volts. Did I get that one right? Oh, we're on a roll here. 8.253 volts, we've got that one. Yes, sir?
Oh, never mind.
Okay, so now we're set, I think we're set to we're going to pop the circuit, okay? We're going to get rid of the stuff that we don't understand, and we're going to turn it into a circuit that we do, okay? So I'm going to ignore, now that I know that the voltage from here to here is 8.253 circuit, I'm sorry, 8.253 volts, right? Now I can draw this circuit a different way, like this. Okay, so that's A2, is that it? This is my 7 ohm. This is my 11 ohm. V3 is across this one, right? And a 13 ohm is over here, right? And there's an ammeter right here, isn't there? Is that A1?
Yes, A1.
Right, and then this guy is 13 ohms. Okay, and the voltage at this battery is 8.253 volts, or more accurately, it's whatever I've got stored in C. Okay, so this guy is what I've stored in C. Right? Is that correct? So now we've got this little thing. What kind of circuit is that? Well, it's strictly speaking, it's like really, it's a series circuit in parallel to a single really stupid circuit, right? Yeah? Okay, and there's a voltmeter across this one, which is, of course, this thing is reading 8.253 volts, this guy, right? But we've already figured that out, right? So that's that reading. That's actually V1, right? So now this is easy. The current in A1 is easy. It's just I is V over R. So it's 8.253 volts divided by 13 ohms. So that divided by 13. This current is 0.63485 amps. And that's the reading on A1. Is that correct?
Yep.
All right. Hey, we're on a roll, right? And then there's another current that goes through here independently, right? So there's two currents in this circuit. The current that goes through here, we can find A2, right? That's going to be V over R, right? So it's going to be I is V over R is 8.253 divided by 7 plus 11, right? So that's alpha C, indeed it is, divided by parentheses 7 plus 11 end parenthesis. I'm going to store that in D. I'm just going to keep going here. Okay, that current is 0.4585 amps. So that's A2, is it? Am I right on that?
Yeah.
All right, that's good. Okay, and now I'm all set. I can find this voltage right here. Yeah, she's here. I can find this voltage right here. And the nice thing is that I already showed you how to do that, right? Right? So that's going to be 0.4585 times 11 ohms, right? So I'm just take this thing that's on my calculator, multiply by 11, and I get 5.04356 volts. Did I? So I guess 4.4. Yeah? Are we good if we answered all of them? What? So basically this is the crux. Here's the crux, right? We can't solve this circuit the way it is. So we reduce it until we can solve it, right? Then we take the voltage across the part that we reduce to make it easier, throw away the rest of the circuit, and just look at that part. Yeah? And then we keep doing that, and that's basically what I need you to be able to solve for this class is to be able to solve a double popper, right? And a double popper is where one of these resistors, say maybe this one in here really is 2 resistors, or something like that, right? Oh my gosh, right? So you have to do this process again, right? You find this voltage here, and then you look at that little whatever that is, right? So that takes some time, but it's not impossible.
But it is.
Yeah.
Are the two resistors on the left side that are parallel this way? Are those, you don't have to treat those like parallel though?
No, they're not parallel, right? Because they look parallel to each other. They're drawn parallel, but the current goes through one, then this one, right? So series means that their ends are connected together thusly, right? And we could draw that in any way we want, right? This is still series. Yeah? So anyway, these things, even though they look parallel, are just still series, right? It's just the ends. Parallel things have their ends connected together, no matter how you draw.